Hey everybody, Ryan here. Just wanted to go through this really quick little solution I made. I've been doing the JavaScript 30 course by Wes Boss. It's really good. I'll put a link in the description for JavaScript 30. Basically, it's just 30 days of vanilla JavaScript coding, just fun little projects and little things you can build to help improve your JavaScript skills. But I already did the day number. This is day number 4. I skipped the first couple because I've already done them, but this is day number 4, and so we're just practicing some useful array methods, mainly filter, map, reduce, and sort. So he has these different. This is like kind of a starter thing. It just gives you some data, and then down here in the comments, he has like different little tasks for you to do, and you can get those from JavaScript 30, and then you just sign up, and then you go and create your account, and he has starter files, and that's what this was originally, I believe. But yeah, so anyway, getting into it. So the first, we just have basically this array of different people, of different names, and then there's this array of objects that are of different inventors. So the first couple, we're just going to use the inventors array. We're not even going to use the people data right now. So the first one is Array.prototype.filter. Basically what filter does is that it will take an array. These are all array methods. So it takes an array, it creates a new array with that, like, depending on the comparison function you pass into filter, it pass this callback, it's going to iterate and apply this function to each member of the array, and then it hands it to you here. So what we're doing basically, and depending on whether or not that function returns true or false, it's going to allow it into the new array that we're building here. So when it returns true, it lets that, whatever this particular inventor object is in the array, so one of these guys, whenever that is, like if this comparison returns true, it's going to put it into the new array. And so what our task is to filter the list of people who were born in the 1500s. So basically 1500 to 1599. So what we're doing is I'm saying from this comparison function, we're just going to return the result of these comparisons. So we're saying inventor.year. So we're getting each inventor, it's iterating over. So we're getting the inventor from here, which represents just one of these entries. We're saying get the right here, yeah, the inventor.year, so the year they were born, and then that has to be greater than or equal to 1500. So that's our first year. So making sure they're born in the beginning of 1500, and then also making sure the inventor.year is less than or equal to 1599. And so basically what this is doing is it's comparing this, because the AND operator is actually, it works a little tricky. It's actually returning this second thing because it's comparing this, inventor.year is less than 1500, and if that returns true, then it kind of ignores this now and moves on to this because it's an AND statement, or AND comparison. And then it compares this. So if this is true, it's going to return, the whole thing's going to return true. If this is false, the whole thing is literally going to return the value false. It's not going to return the inventor object or anything else. It's just returning the value false. And then filter is smart enough to know that when it returns false, to not include it in the new array. However, when we come across two of the guys, so it's Galileo and who was it? Kepler, were both born in the 1500s. So when it comes across those guys, this ends up returning true, and they get put into our new array. And we can check that by going to our array cardio page here, and then checking in here, born in 1500, is an array of 2 items, and we have Galileo and Kepler, and they were both born in the 1500s. If you go back and look through all of these, you'll see they were the only 2 that were born in the 1500s. Okay, the next one is map. Map is a little different than filter. Map is making a one-to-one copy of the array. So basically, it's, if you have an array of length 10, you're going to have an array of length 10 coming from map. Now it might be filled with undefined, but it's still going to be an array of length 10. And the way filter does is the callback you pass to it, whatever you return out of this callback is what's going to get put into the new array. So here we have to give us an array of inventors' first and last names. So we're going over our inventors again. Remember our inventors objects here. And basically what we're going to do is iterate through them, grab the first name and the last name, put them together, and we don't need the years for this one, so we'll just drop them. So what we can do is, I have an inventors, the array, I'm mapping over it. It also gives us the inventor, the first argument, in the and all these array methods is usually the thing with the exception is usually the item you're iterating over, except for the exception of with the exception of reduce, which has the accumulator, but I'll explain that in a second. So basically, Inventors.map, we're taking the inventor, and then we're just returning the string. This is a template literal of inventor.first and inventor.last. So we're just grabbing these strings. So we're taking Isaac and we're taking Newton and we're putting them together. I could also have written this like inventor.first plus string with a space and then plus inventor.last. I could have done it like this. These are interchangeable basically. So we'll comment that out. So but this is just the new fancy ES6 way of doing it. So what we do there, now we have the list of first and last names. We can check that here. First and last names is an array of 12. And look, we just have an array of the strings, the concatenated strings. Next challenge is the sort method. So what sort does is sort's a little tricky, but once you think about it a little bit, it starts making sense. Basically, sort will sort your array from lowest to highest. So if it's an array of numbers, it'll sort it from lowest to highest number. If it's an array of strings, it will convert those strings to their Unicode characters. It actually says it on the MDN page. I'll link this in the description too, because the sort is the one that takes the most, like, at least for me, it took the most like wrapping my head around it. So it's, and reduce is kind of tricky too. I've just been using that a lot longer than sort. So basically it says it right here, yeah. Built upon converting elements into string. The default sort is ascending, built upon converting elements into strings and comparing their sequences UTF code unit values. So it's taking the strings and turning them into UTF-16 code values and then comparing where those are laying. And so it's basically just organizing numbers, but that's how it does it with strings. So what we can do here is, where is it, sort? So oldest to youngest, inventors.sort, and I can pass it a compare function. The first two things that get passed the compare function are, the compare function are the first element for the comparison and the second element for comparison. So basically we are going inventors. The first time that sort runs, this is going to be the current one, and then this is going to be what I called the next item, but it could be, you can call it whatever you want, but I just like that for just to keep my sanity. So current inventor and then next inventor. And so it's going to run this for each item. And then depending on if you return 0, negative, a negative number, or a positive number, that makes it so that the whether or not the sort method will switch those elements in the array. It switches them in place, by the way. I want to mention that too. It's not making a new array. Filter, map, and reduce all create new arrays. Sort does not. It sorts it in place in memory. So just keep that in mind. Okay, so we're taking the first two values. Description, it's a little, you might want to go through reading this if you're having trouble with the sort function, because it just takes a little bit of thinking about. But it's return less than 0, sort A into index lower than B, meaning A is lower than B. So if you take A, say A is like 10 and B is 5, and so you take 10A minus B minus 5, it's going to return greater than 0. Sort B, which remember was 5, into an index lower than A, so it would switch these because it returned to 5. So basically, imagine now, say B is 100 and A is 10, right? So they would already be in order, be 10, 100. So we take 10 minus 100, we get negative 90. If it less than 0, if this compare function returns less than 0, it's going to flip these. Actually, no, it's not. I'm sorry. Sort A into index lower. So if this was 10 and B was 100, it wouldn't do anything because A is already in the index lower than B, i.e. A comes first. So that's what it meant when it was saying ascending. So it'll go from lowest numbers to highest number. Okay, that's enough with that one. That one's a little tricky, but yeah, so I'm taking the current inventor year and then I'm subtracting the next inventor year, and then that's sorting it. So basically, if the current inventor.year, so say the current inventor Albert Einstein was born in 1879, and the next guy, Isaac Newton, was born in 1643, we take 1897, or 1879, I believe, right? Is that, yeah, 1879 minus 1643, and we're still going to end up with a positive number. So it knows that when we have a positive number, returns greater than 0, positive number, it's going to sort B into an index lower than A. So it's going to flip Albert Einstein and Isaac Newton, because Isaac Newton was born before Albert Einstein, because we took their birth years and subtracted them and came up with a positive number. It's just a little math trick. That, you know, if it's confusing, you just gotta, half this stuff you just gotta stare at it until it makes sense, I guess, sometimes. Okay. Let's see, where were we? Okay, yeah. Now we're gonna use, so we got the sort, we got all that, oldest to youngest, and so oldest to youngest is just flipped them around, starting 1443 all the way up. And there's Einstein, and then it put Newton over here. So yeah, after it went through all of them, it sorted it out, so it's in ascending order. Okay, now the next one, how many years did all the inventors live altogether? So this is where reduce comes in. Reduce is the most powerful function of all of these, because you basically can build all these other array methods from reduce. And the magic thing that reduce does is it gives you what's called an accumulator. So the second argument you pass, the first argument is still a callback, just like filter, map, and sort. But the second object you can pass is what's called an accumulator. It doesn't have to be an object. It could be a value. I just did this so I could have it just seemed like weird just having a ghost 0 here, so I wanted to give it a label, so I put it in an object and gave it a label years. But you don't have to. It could be anything here. It could be an array. It could be just a string. I don't know why you would want to do that, but you could, and then just like concatenate it. So basically whatever you return from this callback function is what will get passed to the next iteration in the accumulator. So that's why I was saying how, like, in all these other functions, the first thing you get is the actual item you're working on. In reduce, the first item is the accumulator, and the second one is the item you're working on. So I always, whenever I write reduces, I always immediately return the accumulator at the bottom of my function, because I always forget to. Let's redo this real quick. Years 0. Okay, so what we're doing here is we're saying years lived equals inventor.past, which is the year they died, minus the inventor.year. So we're taking the year they died, subtracting the year they were born, we'll get how long they lived. And so that's the years lived for a particular inventor. Remember, we're iterating over an array for that particular inventor. And then we're saying accumulator.years, so we're accessing this years property on the accumulator object, which I called up here, and we're adding the years lived to it. We're plus adding it. Like I said, if I wanted to just simplify this a little bit, I could just put the 0 there and then just say accumulator.plus equals years lived. So it's just going to add it up there. And now when I do that, I can just get rid of the years there, and it'll work the same exact way. So we'll go here, cumulative years, 861. So all those inventors' ages put together is 161. Moving on. Sort the inventors by years lived. Okay, so in this one, it's a sort. And then, well, first we have to figure out current years lived. Yeah, okay. Yeah, this is what I did here. So we're sorting. We're doing another compare function. We're getting the current inventor and the next inventor. And so we're figuring out the current inventor's years lived. So the current inventor past minus the current inventor year. Same thing we were doing up here. So we're getting the years they lived. And then we're also getting it from the next inventor. We're saying next inventor past. These are both the same operation, just for each value. And then we're just returning current inventor minus next inventor years lived. Oh, wait. I messed that up. Current inventor. No, it'd be current years lived. I messed it up. Let's see if it works now. Current years lived minus next inventor years lived. So we're taking, say, the current inventor lived to be 90, and the next inventor lived to be 100. These will get flipped because 90 minus 100 is negative 10, and sort knows that if it's a negative number, if less than 0, sort A into index lower than B. Yeah, so if it's 90, I think, wait, am I messing this up? So it's, say, current is 90, and the next inventor lived to be 100. Yeah, So A is in an index lower than B because it's 90 and then 100. But let's say if it's flipped, so it's 100 minus 90, we end up with 10. We have 100 before 90, and we want to flip those, so the compare function sorts B into an index lower than A. Okay, so let's just double check, make sure that one worked. So sorted by years lived, past, so let's say, there we go. Actually, okay, so it did work. Yeah, see 37. Okay, cool. So there we go. I figured I fixed it there. I just started attaching, instead of doing all the math, I just attached the a new property on the object, because you can do that in JavaScript just willy-nilly if you want, age at death, and then I just put in the whatever current calculated years was. Okay, so that's sort by years lived. Create a list of boulevards in Paris that contain D anywhere in the name, and then he gives you this link. So what you have to do is you take the link, copy it, you go to this Wikipedia page, and then we have that, we inspect it, and what we want to do is we want to grab these categories. So we have this M category that's got all the lists in it, and we want to cut out these top ones. So we can open up the console, we can say const lit or links equals document dot unit dot query selector all, and you can see I actually remembered what I did before. So we're saying find the category of MW category on this page, yeah, which is over here. So MW category is the whole list, and then inside the list you'll notice is we got a bunch of different elements, but the things we actually want, these values, are located inside of an A tag. So these A tags with the title or the inner text is boulevard, whatever. So we're trying to grab those strings. That's what we're trying to grab right here, is these little strings inside of the A tags. So what we can do is we can grab these A tags by going to console and selecting the category and then all the A descendant tags of that. And we're going to put that in an array called links, or it's actually going to be a node list. So if I say links, you'll see it's a node list of all of our A's. And if we scroll down, we can see inner text is the string we want. So I can just say, but it's a node list. So you can use a for each on a node list, or we can just convert it to an array. So I'm just going to say array.from links, and then we're going to map. We'll use map here, because remember, it's just going to create an array. We want an array of strings. So I'm going to say street, and then we're going to return from our function the name. So all we're going to say is street dot inner text, and then it's going to give us a big array of all of the names, and so we can grab that. And so I did that already here, but then I actually let's do this, delete, and then I put that there. I'm using Prettier, so it auto formats it for me, it puts in a nice list for me, and then I just deleted these guys, the first ones, because the first ones are just an index of the what's on the page. So you want to actually start at Boulevard August Day, whatever. So that's what I do. Cool. All right. So that's how you grab that information. Now it's actually pretty simple to filter them. We just use filter, and then you'll notice here I'm not returning it because it's an implicit return from the arrow function, because Prettier fixed it, but technically I wrote it like this. It's a one-liner, because anything, if it's on the same line, it's implicitly returned from the arrow function, whatever you pass. So I'm returning street name includes .d. So if it includes, returns true or false, depending. Actually, wait, I think it, let's look it up real quick. So we can look up, return true or false is appropriate. So it only returns true or false. It doesn't return the string, but that doesn't matter, because that's what for the filter callback takes. So if it includes DE, which is what we're looking for, anywhere in the string, it's going to return true, and it's going to include it in our DE streets array. And we go over here, and we'll get rid of this guy now. We don't need it. And then we have our D streets, and it has all the boulevards with D in it. Okay, next couple ones here. we have our sort the people alphabetically by last name. I just did a people.sort. It's a little more complex. Like he does a little more complex, but because the data is the way it is, where it's their last name and then their first name, it's just gonna take the string and compare all these B, and they're all B's. So I just did a array.sort. Okay, and then here is a fun little exercise that you might see a lot. It's a popular little program problem. Is sum up the instances of each of these. So see how we have 2 cars, 2 trucks here, bike, walk, another car, van, blah blah, car, truck. So we can, this is a perfect candidate for reduce, and what we can do is use the accumulator again. So we're just going to make a blank object for our accumulator, and then we're going to go over our data here, and we're just going to reduce. We'll grab our accumulator and the string, it's whatever instance we were working at the time, and then the first thing we want to do is to check if the string has already like we're going to use this object to store, like it's going to end up looking like car, and then the count's going to be 0 or 3 or whatever, and then we're going to have a van, and then the count's going to be 0 or 1 at least, and then you know, so that's what it's going to end up looking like eventually, but right now it's just an empty object. And what we're going to do is, as we iterate over it, so it's going to say car, you know, the first thing it's going to run over is this car string. It's going to take that, it's going to say, does the accumulator have the property car on it yet? It doesn't, because it's an empty object. So it's going to put it on there. It's going to initialize it essentially on accumulator dot. This is the equivalent of writing accumulator dot car for this iteration. If we're taking the string here and then we're placing it, and that's how you can actually access objects. So we're saying string. Cool. Okay, so we're initializing it to 0 there, and then we're just saying accumulator dot string is going to equal whatever it was before plus 1. You could also have done plus plus if you want. I don't know why, I just like the plus 1 for some reason. Maybe it's because I do like video games. Or I don't know. I just prefer that one for now. Anyway, and then we return the accumulator. Don't ever forget to return the accumulator, otherwise it breaks. And that's it. So basically, we go through the whole thing. And let's see if it works, because right now I'm seeing some nans here, and that's not good. Okay, so we're getting nans, so let's debug it a little bit here. So we got that. We got accumulator.string. It's there. What happens if I do plus plus? Huh. Okay, so let's look here. Accumulator.string plus equals 1. Okay, let's debug it a little bit here. So we're gonna do that. I'm gonna put a breakpoint here, and then we're going to reload the page. It's going to stop here, and then let's go ahead and open up. So we got local string car. This undefined, who cares what this is? Car is nan, so meaning it's already nan, but we're initializing it to 0 here. Accumulator, interesting. So what happens if I go to next here? Huh. So plus equals 1. So string. Okay, let's put another breakpoint here actually, and then we'll reload the page. We'll see if that's going on. We'll go next. Whoa, what happened? Okay, so we have our string is car and our accumulator is still an empty object. We're going to go in here, and it's not going to. Okay, I see. So if, yeah, okay, that's why. So if no accumulator.string, we're going to initialize it. Otherwise, we are just going to skip over this if, and then we're going to go accumulator.string. So now we do it, and I don't even think I need to check. Well, of course I need to check, but oh, it's paused again. Do that. Oh goodness. Okay, hold on. Get rid of this. There we go. Yeah, so it counted it up. So that's all it was. I switched the logic around a little bit. beforehand. So that's it for this video. That's one of the, I like this solution a lot actually. But yeah, that's it for this video. That was just a simple array cardio. I'll put all these links in the description for different things. This is a really cool course. Definitely recommend you check it out. Please like, subscribe, all that fun stuff. Stay tuned for more. Thanks, guys.